Hello students, today we will solve numerical based on relative stability. Okay, so let's see how the question is asked on relative stability. Find how many roots have real parts greater than -1. I told you that in case of relative stability we are comparing two things. For example, suppose this is S domain. S domain means we know that S is equal to sigma j omega. Okay, so I am showing sigma on x-axis and j omega on y-axis. Okay, and this is origin. For this domain, what we are showing, this is actually S domain. What we are saying, this is actually S domain. Okay, so now what we need to do, first of all, we have to find we have to form the Routh array when the j omega axis is at the origin. Okay. Now what is given here? Here it is given that we need to find the real part greater than -1. Okay. So look at this. This is 0. Now this j omega axis is shifted to new axis. Okay. So I am showing this new axis at -1. Okay. So this is actually -1. Okay. So I am labeling this axis as Z and this is actually S. Now we have studied that in case of relative stability, what we have to do, first of all we have to form the Routh array with the given characteristic equation. So look at this, I am forming the Routh array. So this is S cube, S square, S raised to power 1, S raised to power 0. So I will put the value from the characteristic equation. So this is 1, skip one term, then 25, okay, skip one term, so it will be 0. Next, for S square, 7, then 39, okay, put 0. So multiplying 25 into 7 minus 39 divided by 7. I am repeating, 25 into 7 minus 39 upon 7. So I am putting the value here. I have the answer, that is actually 19.42. And what is coefficient of S raised to power 0? That is 39. Okay. So now I am considering the first column of Routh array. Okay, as we know that if the first column of Routh array is positive, then system is stable, or you can say that all elements in first column of Routh array are positive. Look at this, all elements are positive. So what you will say, system is stable. Okay, system is stable. Okay, but this is the case when the j omega axis is at origin. Now in this question it is asked that j omega axis is shifted at S is equal to -1. So what we are doing generally for such case, we are writing as S is equal to Z -1. Okay. So what we need to do, we need to put S is equal to Z -1 in the characteristic equations. So see, I will get a new characteristic equation. So my new characteristic equation by shifting j omega axis for the new value. Okay. So I am writing here Z -1. Look at this. I am substituting Z -1 cube plus 7 Z -1 square plus 25. So Z -1, okay, plus 39 is equal to 0. Okay. So I have substituted S is equal to Z -1 in the characteristic equation and I got new characteristic equation. Okay. So now I am writing the characteristic equation in Z form. So I have the answer Z cube plus 4Z square plus 14Z plus 20 is equal to 0. So look at this. This is Z cube plus 4Z square, 14Z plus 20 equal to 0. Now I will form the Routh array with the new value of the characteristic equation. Okay. So this will be my Z cube. Next is Z square, next is Z raised to power 1 and last will be Z raised to power 0. So look at this. Here I will put 1, skip one term, it will be 14, then 0. Okay, start with the coefficient of Z square. So this is 4, skip one term, it will be 20. Okay, so what will be the coefficient of Z raised to power 1? Look at this, 14 into 4 minus 20 upon 4. So I have the answer as 9. Now Z raised to power 0. Okay, so what is coefficient of Z raised to power 0? Here I am getting 20. Okay, so now look at this. I will consider the first column of Routh array. Look at this. I will consider the first column of Routh array. What is your observation? There are no sign changes. Look at this. All terms are positive. All terms are positive. Okay. So what will be your conclusion? As all terms are positive, so system will be stable. I will write here system will be stable. System will be stable. Okay. After shifting j omega axis at new value. Okay. But what you have to understand, instead of writing only system will be stable, see previously also system is stable. Okay. When this j omega axis is at origin, we are saying that system is stable means all roots are on left hand side of j omega axis. Look at this. We said that all roots are on left hand side of j omega axis. So we have concluded that system is stable. But now this j omega axis is shifted to the new value. Okay, that is at -1. I have labeled that plane as z plane. I have substituted s is equal to z minus 1. Okay, I have recalculated the characteristic equation in terms of z. Okay, and again what I got here, I got all terms as positive. Okay, so what will be my conclusion now? As there are no sign changes, all roots will be on left hand side of this new j omega axis, means this z, left hand side of this z. Okay, so what is your conclusion? As the roots are away from this new axis, that is away from j omega axis, system will be more stable. What I will write here? System will be more stable. Okay, so I hope you got the concept of relative stability when we are shifting j omega axis to new value. So actually we are checking the location of roots, whether the roots are on right hand side or left hand side. See, suppose I am getting here some sign changes. In that case, irrespective of the previous stability, if I am getting negative sign here, so what I will write here? System will be unstable. See, I will write system will be unstable because why I am writing system will be unstable? Whatever roots I am getting, that will be on right hand side of this z plane. See, that will be on right hand side of this z plane, but that roots will be within this range. Look at this, that roots will be within this range. Okay, so actually system is stable. Actually system is stable by shifting, but what you will say? Now the roots will be within this origin and between this -1. Okay, so relative stability says that when the roots are far away from j omega axis, then system is more stable. Okay, so I hope you got the concept. Thank you, students.